Welcome to the Basic Principles of Radiation Continuing Education activity. By the end of the presentation, the individual will be able to define ionizing radiation, correlate wavelength, frequency, and energy, differentiate milliamps and kilovolts, describe how X-rays are generated, identify the parts of an X-ray tube and the image intensifier, describe line focus principle, and discuss 3 reactions of photons when entering a material or patient. So let's first discuss the discovery of X-ray. In 1895, Wilhelm Röntgen announced the discovery of X-ray. The very first medical radiograph was an image taken of his wife's hand. In 1896, the first cases of somatic damage caused by ionizing radiation were reported in Europe. And between 1895 and 1900, Thomas Edison worked with his assistant Clarence Daly to create a more defined or refined, sharper image picture, so they were working on what people were calling the Edison X-ray tube. The purpose of the Edison X-ray tube was to develop a fluoroscope that had the sharper images than the X-ray tube that was developed by Röntgen. In 1900, Mr. Daly started suffering radiation damage to his skin. Early in 1902, Mr. Daly had his left hand amputated, followed by 4 fingers on his right hand. In late 1902, Clarence Daly became the first American radiation fatality. By the time he died, he had one arm amputated up to the shoulder and the other arm amputated to the elbow. After Clarence Daly passed away, Thomas Edison abandoned X-ray work because he was afraid of the unknown of X-rays. So what is radiation? Radiation is the process of emitting electromagnetic energy in the form of waves or particles through matter. It may also be defined as the combined process of emission and transmission of radiant energy through space. All radiation is electromagnetic energy. So let's talk about the correlation between wavelength, frequency, and energy. Energy that travels in waves is characterized by its wavelength. We can see evidence of this when we look at the electromagnetic spectrum. The electromagnetic spectrum describes the distribution of electromagnetic radiation according to energy levels. X-ray energy is at the higher end of the spectrum, and its wavelength is pretty short or close together, such as that in an accordion, which means it has a higher energy. Forms of electromagnetic energy at the lower end of the spectrum, such as visible light, infrared light, and radio waves, are composed of longer wavelengths. So if you look at this continuum, this is our electromagnetic spectrum. We have on the far right side low frequency, low wavelength, very far spaced out and spread apart, radio waves, infrared light, and visible light. As we move to the left on the spectrum, our wavelengths go from very spread out, getting a little bit tighter, and as we get over here to gamma rays, they are very close together. What also happens is if we look at this as a thermometer, our radio wavelengths are pretty low heat and mild, and as we again move down the spectrum, the temperature heats up. So as we get to the X-ray and gamma ray, we are producing a lot of heat. So the correlation is the shorter the wavelength, the higher the frequency, therefore the higher energy. So here are your short wavelengths, high frequency, high energy, gamma rays, and X-rays.